Okay, so with the two sneaky number problem, we are supposed to return an array of size 2 elements containing some numbers, and those numbers, when you read this particular point, it says each number was supposed to appear exactly once in the list. However, two numbers sneaked in, and so once we have our, so in this example, we have our nums here, and you know that the duplicates are 1 and 0. Same applies to this, so it's sort of finding duplicate, all right? And so with this with this example 3, you would realize that 4 and 5 are the two mischievous numbers. And we're not going to be giving an array of size which is more than 100. Everything is between 2 and 100. In this particular one, if you want to find the length of the original array, it's just the length that we're giving minus 2, and that would give us the length of the original array. Alright. And we are guaranteed, so they say the input is guaranteed such that nums contain exactly 2 repeated elements. Alright. And note that the elements are not negative, they are all positive because they are between 0 and 100. Okay, alright. So with this problem, what I'm thinking, so with the brute force approach, we just have our counter, and so once we iterate through, so for each number we are going to, for each element we are going to also iterate through. Once we see a duplicate, we increment the counter, we check if the counter is let me just write this thing down. So copy this. Okay, so result of like the brute force, that solution that comes into mind, I'll have my result, so I'll just store my result somewhere. Alright, and once I have my results, this is just a result variable, something like that. Alright, and once I have that, I'll just iterate through. Let's say I iterate with an I, then I iterate through again, let's say with a J, then I compare the elements if they are the same. So compare elements I and J, if they are the same, then we increment the counter. So of course we also have a counter here. Okay, so we increment the counter, and once we increment the counter, we also check if the counter is greater or equal to 2. No, because it's exactly 2, we can just use if the counter is equal to 2, and once we realize that I and j are the same and the counter is equal to 2, then we just add the results, add to the results. Alright, so let's code this up in Java, of course. Alright, so I'll go ahead and copy this. Alright, okay, so that's our return type, which is an int array. Okay, so what do we have here as our solution? So we actually use an I attribute in the J to do a comparison. Alright, so first of all, we store a result. So let me see a list of integer results equal to new array list, and we have our counter, and counter is equal to 0. Alright, and we iterate through. First of all, with an I, for int I is equal to 0, I is less than the nums dot length. Since I'll be doing dot length, let me just have a length here is equal to nums dot en enghc. Alright, it's less than the length, then I plus plus. Alright, so we also iterate with a j. So for int j is equal to 0, then I is less than the length, then j plus plus. What we do now is to compare the elements. So if nums of I is equal to nums of the j, so if the elements are the same, we'll first increment our counter. Alright, so we first increment our counter, and once we've iterated through, we just make the condition that if, with this particular condition, if our counter is equal to 2, so if our counter is exactly 2, alright, and we just add it. But the thing is, we'll have to check if it's not in there, because then it means we'll end up, once we see the first keys, we just add it to it. So if our counter is exactly 2 and the result that we have here dot contains, so if the result doesn't contain or do not contain the nums of I, then we just add it to the result dot add the nums of the I. And so once we are done, our counter then becomes 0, because we start the counting all over again once we see a duplicate on the iteration with a G. Alright, and we just return the result. So the result, this is a list, and so we are supposed to return an int integer array. So I'll just return a new int, and my result dot get 0, then result get 1. Alright, so I'll go ahead and test it. I do have the inputs, so these two inputs I do have it locally, so I can go ahead and test them. So I have them here, and oh, okay, so I just, okay, so it's compiled, not find symbol length. Oh, okay, and in this for out of bounds of length 4, so we have one test fail. Alright, so what's happening here, we have our length of nums, we move to the length, if nums I is equal to nums of j, we increment our counter, okay. So I think this is the issue here, j is less than length right here, and so we run our application again. Okay, alright, just scan the class path, and we have one successful test. Alright, so we can put that in there, everything, and submit. Alright, so we it passed 7 out of 6 out of 7 out of 6, 706, 706, and so that is good, but I think we could do better. Alright, we could do better, because I think we've been given a hint here which says that to solve the problem without extra space, even with this, we're not even using extra space, but let's see, using extra space, if we'll be able to come up with another solution. Alright, so obviously this is bad, this is very bad. Instead, or in this case, if there's a way of making this thing better, I think we should, because, and we can, right, because we can use the idea of we have a hash map where we have our key value, and our keys would be the let's see, the elements in there, which is, let's see, the elements are, let's say, x, and the values will be the frequency of the how do you call it, the x. All right, so for something like this, let me take this input here. Let me just make it x, then frequency of x, then put it that way. And so if I have this particular input here, so I can my map, I can have a map constructed for me in this way, where 0 is 1. So I would iterate through the particular list. So first of all, we can iterate through, we just iterate. Then we have, so once we come into contact with 3 not being inside the um, map, so we check if it's inside the map. If it's not inside the map, we just add it. So we so let me just say inside the map. If not, then add to the map. Then with frequency of the occurrence. So the first time we met 0, it's 1, and once we meet 3 here is 1. Then we move to 2 here is 1. Then we move to 1 here is 1, and we meet 3 again. And so once we meet 3 again, if it's inside the map, so this one is so if it's not inside the map, we can go ahead and do this. But if it's a yes, if it's inside the map, we just take this particular value and increment it by 1. All right, which will be 2 in this case. All right, we increase it by 1. So let me just remove all this and make it 2 and put here. So get the value increment plus 1. Get the value increment it. All right, just put here plus 1 here, and that's 2. And once we have this particular one, we increment the value. We will just check if that value is equal to 2, because now that we need exactly 2 output sides. And so if that value is 2, then we just add to the result. All right, so we'll have to have our result variable, or only a result store. I don't know. All right, yeah, we'll have that as a result store. And so once we meet 2 here, we come here, we increment with 2, we increment by 1, which will be 2, and at the end of the day, add to the result. So add key to the result. Okay, so I think let's try this particular approach. And so we still have our result, and let me move this particular counter here, and so we'll have our map. So let me go ahead and do that. So we have our map, integer, and key values are going to be integer. It's going to be my map. Go to new hash map. Alright, so that's my hash map, and my hash map is initially empty, and so I will look through. So let me just delete everything here. Let me say for int num in my nums. Alright, so we're actually going to do this. So the idea was, is it inside the map? If no, then add it to the map. In any case, once we've incremented, we will add to the map. So I'll say my map, the put. So the key is going to be num, and the value is actually going to be my map dot, let me get this particular num. So I can use get or default to 0. So if that particular num it's not in there, I'll get a 0. Then I'll increase it by 1, because it's storing the value and the frequency of occurrence. And once you meet the first value, automatically it's 1. So 0 plus 1 here is 1. Okay, so that's That's for putting the number and the occurrence in there. The next thing I think we'll do is to, alright, so if the value is 2 and also so for the yes and no. Alright, so we just see if my map dot get that particular num once the value is equal to 2. Alright, then append to my result. The result will add that particular num, which is my key. Alright, then at the end of the day I return exactly 2. So let's see our test. So the same test over here. Alright, so it's passed, and I'll copy everything here, copy everything, go here, paste it, and just submit it. Alright, so this also passed, which is this 706 out of 706 test cases passed. So so it's okay. But the thing is, we can actually improve this thing if you look at it critically, because there was a hint in there said we'll come back to it. So it says that to solve the problem without the extra space, we need to think about how many times each number occurs in relation to the index. So it is very important how each number occurs in relation to the index. Alright. Okay. So we see that our solution takes an extra space. So when we take a look at the hint here, it said to solve the problem without extra space, you think of how many times each number occurs in relation to their index. Alright, and I think there's a classic trick to detecting duplicate with this particular approach. Alright, and the idea is that considering, let's say I have nums, and my nums are 0, 1, 2, 3, 1, and 3. Alright. Okay, so let me make this one a 2 here. Let me make this one a 1. Let me make this one a 2. Okay, so let's say I have this nums. Alright, once I see a 2, how do I know that when I get to this particular 2, I've already seen a 2? What are the things I can put in place? Alright, now we already know a couple of things. So the first thing is the length. Let me put all this thing. Let me just copy everything here. Let me just copy everything here and just bring them here. So we know that the length is our n is equal to is our n plus 2. So the length of this, or the size of this right now, is 6. 1, 2, 3, 4, 5, 6. And so 6 is equal to n plus 2, and my n here is 4. And so the original list was 4, and we had 2 mischievous elements in there. Alright, our second case is that the elements themselves do not go past n. So when we look at everything in nums, you can see that they are between 0 and n, and in this case our n being 4. Alright, so we can replace this and say 4. They don't go past 4. Alright, and that's interesting. Alright, that's interesting because you can look at all the examples and you would find that particular pattern in there. Alright, so all the integers are in the range of 0 to n, or well, technically n minus 1. So let me just write these statements down. Okay, so now we know that all the integers that we have all the elements x are in the range of 0 to n minus 1. Alright, and so you would realize from here that this one is inclusive, this one is exclusive, and so they're in the range of, I can just see this, remove this, and see less or equal to 3. Alright, because 4 minus 1 is 3, and you can see that here. So we can use the array itself to keep track of how many times each number has appeared. Alright, and this is what I said about we having a classic trick for detecting duplicate. Alright, so when I have this, how do I know that when I get here, how do I know that I've already seen 2? Alright, and so once I'm iterating through at, let me just bring this one down here. So this has index 0, index 1. So at index 1, once I do my nums of that particular index, I see a 2. Alright, I see the element 2. I see element 2, and that is my x. So my x, my index at index 1, once I compute my nums at that particular index, I get the element x, which is 2, and that 2 is within this particular range. Alright, and so now when we follow this particular hint, they said we need to think of how many times each number has occurred in relation to the index. So I can say that, so if I say nums of the element itself, the nums of the element itself, I'm using the element as an index, right? So let's see, 0, 1, 2, it falls on the 1. What I can do is that, so this brings to the first classic trick, which is negation. So I can negate the element over there. So over here, my nums at index 2 or at element 2, so element 2, so 0, 1, 2 is 1. What I can do is I can negate that. So in that case, my new nums then move from this, comment this out, oh, I can comment this out here. My new nums then becomes this negative 1. Now this is actually a good thing, because the next time we happen to see a 2, so let's compute to 0, 1, 2, 3, 4. This is at index 4. So at index 4, my x now becomes my nums at that particular index, which is equal to 0, 1, 2, 3, 4, which is equal to 2. Meaning that we've seen a 2, so my x is 2. And so once I compute my nums of x, 0, 1, 2. So know that this is my new nums. So 0, 1, 2. I see a negative. So the next time I do this, so this is the second occurrence. So this is the second occurrence. So the next time I see this, the value is going to be a negative number. Alright. And so once I see a negative number, the value is going to be a negative number. And so in that case, I have a duplicate, or I have already seen that number. Alright, in that case I've already seen that number. Alright, and that means I've seen a duplicate, and I can use this sort of idea. Alright, but someone would say that I am actually changing this. I'm not actually changing this number. I can get this number by using absolute, because I definitely know that my elements are within this particular range, which is 0 to n minus 1. Alright, so there's no negative there. But with this particular okay, let's go ahead and code this particular solution, and we'll notice an interesting thing here. Alright, so let me just clear everything here. Okay, alright, so this is the idea, we use the same array, the array itself, to keep track of how many times each element has appeared. And in order to find a second occurrence, we are going to replace the element at that element's index. We're going to negate that, and to be able to get back the value, we just use an absolute to get back the value. All right. Okay. So for int I is equal to 0, I is less than the length of nums, so nums.length, then I plus plus. So what I do is that I'm going to actually, so the thing is, once I'm going through, all right, I wouldn't know if whether I've already negated that point, that element, because the value is going to be negative, right? That on the second occurrence. So with this, I'm taking the index. I'm doing a nums of the elements. I'm using the elements as an index, which is actually going to vary. Okay, so I already know at which point I've made I've negated the particular element, and so I can't take the element literally. I have to use an absolute to get that particular element, and so that's what I'll do here. And so I'll see that, let's say int x, that element is going to be math that absolute of my nums of I. Alright, because I can't just do nums of I. Once I do nums of my index, it could be a positive value, but it could also be a negative value if I had already gone through one iteration and I had modified a particular section of the array. Alright, and so I'll check that particular so this is my x, and so if my nums of I, alright, that particular element, if it happens to be less than 0, or if it happens to be negative, as I was pointing out here, it means that I had already seen a duplicate. Alright, and so in that case, I'm just going to add it to my result. So let me just have my result here, my result being a list of my integer result is equal to new array list, and I'm actually going to add it to my result. What's happening? Result dot add. I'm actually going to add the nums. So that's this. If this nums of I is less than 0, then it means what actually caused it, or what actually made it, is the particular x over here. Alright, else if it's not a negative value, then I'm actually going to negate it, because it will be the first occurrence of it. And so this is the first occurrence. I just have this here. I'll just negate it. Alright, and so once I negate it, then I can just return my answer. So I can just return a new int, and just the result that get 0, and just the result dot get 1. Alright, so this will actually work, but the 0 is going to be a problem. Right, so let's see, because let's see our test case. Let me just take this test case out. Alright, and then basically test only this particular scenario. Okay, so we have result dot get, sorry. Alright, so we've compiled it, and let me just run it. Alright, so you see index 1 out of bounds. The thing is, if I'm to just run this particular solution, so let me just bring this one here. Let me just take everything here, and let me just come to my main method and just my app is going to new app, and I just do just print it out. So I'll just So system.out.println. So I can say I read that to string my result for method 2 here. Let me just compile java app.java. Gonna find symbol. So is it arrays? Alright, so if I test this particular method over here, java app.java and java app, we get what's happening. Okay, so if the nums of x, because note that that's what we are doing, the nums of x. Okay, so if the nums of x is actually less than 0 on the second occurrence, alright, on the second occurrence, if the nums of x is less than 0, and so we add that. So let's go ahead and test it. And so you see we have 3 2 here. We'll go ahead and run our test also, and you see that our test passed. Run them. Alright, you see that everything passed. But let me comment this thing out, and let me just uncomment this, and let's see. So I compile and I run, but that one fails. Alright, that one fails. It fails. Alright, because of my test. But let me bring that same test results here. So let me in place of this, let me just compile that. Java app to Java and Java app. Okay, so I'm also getting the same thing here. Alright, so that is a problem, and we will face a problem at this particular, not this particular index, but we would face a problem, and the problem that we will face, so let me just write it here. Alright, so the problem is when the number itself is 0, when the x is 0, negating 0 still gives 0, and so we can't tell if we've already seen 0, and that's a big problem. So how can we use the array itself to keep track of how the elements, how many times each number has appeared? Alright, so let's see for our 2 here again, when we meet another 2, how do we determine if we can use this negation, since we are facing a particular problem here? So the other approach, let me just do this problem here, the other approach is to use an offset, and this particular approach is cool because what we are doing here is the idea here is to increment the value at index x by n. So this is what we are doing here. So I'll just pick up this particular. Come here. So say we have nums and nums from our earlier example. We can see that, okay, this is at index 1 here. So at index is equal to 1, we have, I can say, so my x becomes my nums of my index, which is 2, and so my nums is 2. Alright, since all the nums are in the range of 0 to n minus 1, alright, initially the first occurrence, so my first occurrence, nums of x, when I do nums of x, so 0 1 2, which is 1 here, just 1, this one will be less than n. And you can see that that number is less than n, and our n, we've already said here, is 4. All right, from our calculation, it's less than n, which is 4. That's the first occurrence. So we continue. Once we meet the second, or once we meet 2 for the second time, then we'll have a second occurrence. So in the second occurrence, the nums of actually x, all right, going by this offset to increment the value at index x by n. Once we pick one on our first occurrence, once you see it, so index of x 0, 1, 2 here would be 1. So it would be 1. Instead of negating or making negative 1, we offset it by to increment the value, and the value is 1. So the value becomes 1. We increment the value at index x by n. So we add n to it, and the value becomes 1 plus 4, which then becomes 5. Okay, so in that case, my nums now become 0, 2, and this place becomes 5. Alright, but you would see that we are changing the value from 1. The value was 1, we change it to 5. Alright, that shouldn't be a problem, because we can get the value. Alright, once we apply a modulus. Alright, so this was 1. Once we just get that number or that value, the value modulo n, we'll get back our value here was 5, and so 5 modulo my n, which is 4, is 1. And we can go back. So we are not actually changed. So once you use a modulo, you can just do this kind of conversions. All right, good. So on the second occurrence, once I do my num of x, so my num of x would be, so on second occurrence, the index would be 0, 1, 2, 3, 4. So my index would be 4. Then my x now would be my nums at that particular index. So 0, 1, 2, 3, 4. So 4 here, which is 2. Alright, so on my second occurrence of nums at that particular index, so nums at that particular index, which is 0, 1, 2, it's not 1 here. This is my new nums. So we can count 0, 1, 2. It's 5. That value is 5. And you can see that 5 over here is actually greater or equal to n. Alright, actually greater or equal to n. And we can duplicate, we can go on and on and on. So let's see if we had a third. So this is the very first occurrence. What you are doing, this is the second occurrence, and this is the third occurrence. Isn't good to even use occurrence, but let me do it that way. All right. So second occurrence is after seeing once. So let me just say after seeing once, and my third occurrence, let me just see after seeing twice. All right. Then at that point, my nums of I, or my nums of x, all right, is actually going to be a number which is greater or equal to 2n. All right, it's going to be a number which is greater than 2n. All right, and so to be able to count at any point in time the number of times we've seen x, so let me just see over here. So to count at any point the number of times we've seen x, we can use this. So our count would be our num of x divided by n. All right, so we can actually do that. So on our second occurrence here, my nums is actually going to, once we've increased, because at the second occurrence we are going to have increased, after seeing twice, we are going to have increased the value. So the value would have been 5 plus the n, which is 5 plus the 4, which is 9. Alright, and at that point, to get the x, I said is the value modulo n, which is still 9 modulo 4, which is 1. Alright, then to get the count at that point, once you follow this particular, at that point the value now becomes 9, and 9 divided by 4, integer division of course, is 2, and this is the number of times. Alright, so I think this is somewhat confusing, but it is pretty straightforward, right? It's pretty straightforward, and we can implement that in Java. So I'll just clear it in here, and so we'll be referring to this a lot. And so using the offset, we've already established this condition to be true. Alright, so I can copy that, and I can just see right here that int n is equal to the nums. So let me just do an int length here is equal to the nums dot length. Alright, then int n, my n here is actually the length minus 2, so the length minus 2. Alright, so that's it, and I'm just going to loop through. So for int I is equal to 0, I being less than my length, and I plus plus. Okay, so what I'm doing is, instead of the negation, I'm going to use an offset, and just as we did before, we wouldn't know if we had offsetted already, and so we would have to get our original value. And so the original value here is actually going to be the I think we made mention of it over here, where we have the modulo. Alright, so is going to be our value modulo n, and our value that's coming inside is the nums at that position. Alright, modulo n. Alright, so once we have that, then we'll go ahead and apply our offset. So our offset is the nums at that particular x, alright, plus equal to n, and so this is the offset. Alright, and so we are going to check the occurrence, and so if the nums at that particular x, alright, divided by n is equal to 2. Alright, so we expect only 2 values, and to get the count we apply this particular formula. Alright, so we just seeing if the occurrence is 2 times. Alright, then we add it to our result. So our result dot add that particular x, and until we are done, we just return our result. So let's, using the same approach, let's test our solution. So alright, and let's go. Okay, so one test was successful, and so let's copy the whole thing here, Alright, and let's submit this particular solution. Alright, and so you see that one also, I think it's much faster. This is much faster, and the test case is passed. Alright, so since we've gotten the optimal way, we can just rewrite the same thing in Python 3. So I can go to my Python 3 here, submit a solution for Python 3 as well. Okay, so let me submit a solution for Python 3. So we know our n. I can look at the Java equivalent of it here. So we compute our n and we do that. Okay, so our length would be length of the nums, of course. Then our n would be our length minus 2 over here. We loop through for I in range the length. Alright, and so what we do is that we computed our value, and we can bring all this. Okay, yes, we can do that. My x is equal to my nums at a particular I modulo, because we wouldn't know if we had offsetted already, modulo n. Okay, so let's go ahead and apply the offset. The offset is still the same thing, which is nums of, just copy this one here, nums of x. Now just go to nums of x plus that particular n. And so what we did over here is to check if the number modulo 2 is equal to 2 after we add the result. So I think I can do let me copy the same thing here. Alright, this is not a Python syntax, so you can say if the nums of I divided by n is equal to 2, so I can have my result here. If it's an empty list, the result that append an x here. Okay, we do the append x, and we just return the results. Okay, so let's test that in Python. So I have my test cases here as well, so we test that. Okay, unexpected indent. Oh, okay, control. Alright, okay, so we have an error, result not defined. Oh, okay, so we just do this. Alright, so our test case run. I'm just going to copy that whole thing, go into my solution, apply the self because it's a class, and submit the solution. Okay, so we had a wrong answer, so the output was 0, but it's expected 0 1. Okay, I think it's from this. So let's see. Alright, so we submitted a solution and 706 test cases passed. Alright, that should be it.